In this lesson, we're going to be looking at angle properties of triangles. The outcomes we're going to cover are: describe and illustrate angle properties of triangles, explain using examples why a given property does or does not apply to certain polygons, identify and explain an application of the properties of polygons in construction, industrial, commercial, domestic, and artistic contexts, and solve a contextual problem that involves the application of the properties of polygons. So we have a lot of terms in this particular chapter. I'm going to start with some terms with triangles. The first is an equilateral triangle, which is a triangle with all equal side lengths. And as a result of all the side lengths being equal, all the angles are equal, and it can also be referred to as an equiangular triangle. An isosceles triangle has exactly two equal side lengths. So if it has three, it's equilateral or equiangular. If it only has two side lengths equal, it's called isosceles. And the third type of triangle would be a scalene triangle, and that's a triangle with no sides equal. We also have to look at the triangles in terms of their angles. An obtuse angle is an angle that is greater than 90 degrees and less than 180. And an obtuse triangle contains one obtuse angle. An acute angle is an angle that is greater than 0 but is less than 90 degrees. And an acute triangle will only contain acute angles. Every triangle has two acute angles. It's the third one that's the important one. So every triangle has two of these. A right angle is an angle that is exactly 90 degrees, and a right triangle contains a right angle. The other two are going to be acute, and the third angle is going to be a right angle in a right triangle. And lastly, when you look at the sum of angles in a triangle, they always add up to 180 degrees. No matter what triangle you have, what type, whether it's equiangular, isosceles, or scalene, whether it's an obtuse triangle, an acute triangle, or a right triangle, it's going to have the sum of the angles equal 180 degrees. So we have an example here where we're going to look at the measure of the interior angle in this scalene triangle. It's a scalene triangle because it contains no equal sides, and by inspection it should be fairly obvious that none of the sides are going to be equal in length. So to find the measure of each interior angle, we're going to put it in this chart. We're going to need to get a protractor. So I have a protractor that I've added to the triangle. And it tells me, when I look at this right now, that the first angle in my triangle is going to be 33 degrees. So I'm calling that angle 1. It's 33 degrees. Now I'm going to move my protractor to the next angle, which you can see I've done here. And when I do that, it appears that my angle is now 85 degrees. So I call that angle 2 85 degrees. Now I'm going to rotate my protractor and move it on top of the third angle. And when I do that measurement, it gives me a value of 62 degrees. So I have angle 3 is equal to 62 degrees. So which angles are equal to each other? You'll notice I've included the table on this slide as well. So which angles are equal to each other? Well, none of them are equal to each other. One is 33 degrees, one is 85, and one is 62. And we want to classify each angle as right, obtuse, or acute. remember that right angles are 90 degrees exactly. Obtuse angles are between 90 and 180 degrees. And acute angles are between 0 and 90 degrees. Angle 1, angle 2, and angle 3 are all between 0 and 90 degrees. So that means that all three of these angles are going to be acute angles. How many of each type of angle does a scalene triangle have? Well, I'm going to set up a little table here. I have acute, obtuse, and right angles are the types of angles that I might see in a triangle. And the number of acute angles in the triangle is 3. The number of obtuse angles in the triangle is 0. And the number of right angles in the triangle is 0 as well. So do scalene triangles always have this number of each type of angle? Will every scalene triangle have 3 acute angles and no obtuse or right angles? No, there can be right scalene triangles, and there can be obtuse scalene triangles. So here we see 2 examples. The triangle on the left is scalene. None of the sides are equal in length, but it does contain a right angle. The triangle on the right, that is also in a scalene triangle. None of the sides are equal in length, but the largest angle in that triangle is between 90 and 180 degrees. So that would be an obtuse triangle. So to summarize this slide, this lesson, there are 3 types of angles. You can have an acute angle between 0 and 90 degrees. You can have a right angle, which is exactly 90 degrees. And you can have an obtuse angle, which is between 90 and 180 degrees. And there are 3 classifications for triangles. The first is an acute triangle. And acute triangles are triangles where all the angles are between 0 and 90 degrees. You have a right triangle if one of the angles is a right angle. And you have an obtuse triangle if one of the angles is an obtuse angle. And again, an obtuse is between 90 and 180 degrees. Triangles can also be classified another way, and that's in terms of their sides. Or also in terms of their angles. In a scalene triangle, all the angles have different measurements. So all the sides are different and all the angles are different. In an isosceles triangle, exactly 2 angles are equal in measurement because 2 sides are equal in measurement. And equiangular triangles, also referred to as equilateral triangles, all 3 angles are the same. In that case, they're all 60 degrees. Of course, in equiangular, they're also equilateral, so that means that all the sides are equal. Now, the reason they're all 60 degrees is because we know that they're all equal. And the last point here, the sum of all angles in a triangle is always 180 degrees. So 60 plus 60 plus 60 will give you 180. That's why an equiangular triangle will always have 60-degree angles. Now, if you have a right triangle, one of your angles is 90 degrees, which means the other 2 combined have to be 90 degrees in total. That is why we say that we know there are going to be 2 acute angles in a right triangle. In an obtuse triangle, in an obtuse triangle, one of the angles is between 90 and 180 degrees. That means that there are less than 90 degrees for the other 2 angles to add up to. So both of those angles must be acute in a situation like that as well.